नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार, फैकल्टी ऑफ कंप्यूटर ऑर्गेनाइजेशन आर्किटेक्चर। कैसे सब लोग, मैं स्वागत कर रहा हूं हमारा COA का प्रीलिम्स का ESE सीरीज के लिए। बहुत सारा क्वेश्चन है डिस्कस करने का, जल्दी से जल्दी ज्वाइन करो बेटा। हम स्टार्ट करेंगे COA प्रिलिमिनरी एग्जामिनेशन का यूट्यूब सीरीज। चलो, लेट अस स्टार्ट द क्वेश्चंस। Let us start from the first question. So what is this question answer? The incorrect match. They're asking the incorrect match. So what is the incorrect match? COA is one of the important topic for the ECE people. ECE people, they are having the important topic for this. So those whoever are in the live, please try to answer, please try to respond. एक बार ऑडियो वीडियो कंफर्मेशन कर दीजिए बेटा, ऑडियो वीडियो सब कुछ क्लियर या नहीं, ऑडियो वीडियो सब कुछ क्लियर या नहीं, मुझे एक बार वॉइस कंफर्मेशन कर दीजिए। ऑडियो वीडियो सब कुछ कंफर्मेशन कर दीजिए बेटा, ऑडियो वीडियो क्लियर या नहीं। फटाफट फटाफट। या इसका आंसर क्या हो सकता है, जल्दी बताओ। वेटिंग फॉर योर आंसर। जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए बेटा, इसका आंसर क्या हो सकता है। चलो, so if you see this question, the incorrect match, they're asking the incorrect match where n greater than 1. Okay, n greater than 1 means multiple. Okay, multiple. Okay, so what could be the answer for this? So first of all, you should understand what is SISD. So you should understand these words. So what is SISD? SISD means what? SISD means what it stands for. SISD means what? So SISD stands for single instruction, single data. Single instruction, single data. So single instruction, single data means it is having only one instruction, only one category of instructions and only one category of data. So if you see this SISD model of computer, so single instruction, single data, so one control unit is sufficient, one ALU is sufficient, so this is true. Next comes SIMD. Next comes the SIMD. So what is SIMD? Single instruction, multiple data. Single instruction, multiple data. So it is having single code, but that code has to be executed on multiple data types. So for this case, as multiple data are there, definitely to handle that, multiple arithmetic logic units are required. So this is also true. This is also true. Next, MIST. So what is MIST beta? Jaldi se answer kar lo. EC people for this subject, good weightage is there, so miss mat karna. So MIST, how can we define? MIST, how we can define? Multiple instruction, single data. Multiple instruction, single data. So as it is having multiple instructions, definitely for multiple instructions we require multiple control units, and we require n ALUs. Why? Because it is having multiple instructions, so multiple instructions handle करने के लिए multiple control units and multiple ALUs चाहिए. So this is also true. Next, but if you see the MIMD, for MIMD, what is MIMD? MIMD stands for what? MIMD stands for what? Multiple instruction, multiple data. Multiple instruction, multiple data, my dear. So for multiple instruction, multiple data, multiple instruction, multiple data. So we're having multiple instructions, so multiple data. So definitely we need n control units and n arithmetic logic units, but he has mentioned only one ALU. So this is the incorrect match condition. So it requires n control units and n ALUs. So for this question he is asking the incorrect match. So the right answer is option D hoga. Chalo. Let us go for the next question. Try to answer this question. ESE 2011 का सवाल है, जल्दी से जल्दी आंसर कर लो बेटा फटाफट. Try to answer this question. What can be the answer here? See here, जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए बेटा. 4 मेंबर्स वाचिंग कर रहे सेशन को. So here, which of the following are the problems? Which of the following are the problems with using millions instructions per second as a measure for comparing computer performance? It does not take into account the capabilities of instructions. MIPS can vary inversely with performance. MIPS varies between programs on the same computer. MIPS varies between the programs on the same computer. So first of all, what is MIPS? So MIPS stands for what? MIPS stands for multiple instructions per second. Multiple instructions per second. So MIPS stands for what? Multiple instructions. Multiple instructions per second. Multiple instructions per second. So that means how many instructions this particular computer is going to be executed, that depends upon what parameters. See here, which of the following are the problems with using MIPS? It does not take into account the capabilities of instructions. Yes, if you see the instructions are basically categorized into 2 things. One is a CISC, other one is a RISC. Complex instruction set computer, reduced instruction set computer. Complex instruction set computer and reduced instruction set computer. So if you see this complex instruction set computer and reduced instruction computer, here the instructions are complex, so they may take more time. Here the instructions are reduced, so there will be faster execution. So but the quality of instruction will be more in the CISC, the quality of instruction is poor in the RISC. So it is not considering the quality of instructions, it is only considering the number of instructions. So this statement is true. Next, MIPS varies between programs on the same computer. Yes, that is also, suppose one program may require some number of instructions complicated, some number of instructions less. On the same computer you may be executing a control program or you may be executing arithmetic program. So program to program the MIPS will differ. So 8 and 3 are correct, but MIPS can be inverse with performance? No. The more is the MIPS, the more will be the performance. So equation 1 and equation 3 are the true statements. So option C is the right answer. So let us go for the next question. Yeah, try to answer this question. ESE 2002 का सवाल है, ESE 2002 का सवाल है, जल्दी से जल्दी आंसर करने की कोशिश करो बेटा, इसका आंसर क्या हो सकता है। आंसर प्लीज, इसका आंसर क्या है। जितने लोग लाइव में हैं मुझे एक बार हाई दिखाइए बेटा। हाउ मेनी ऑफ आर वाचिंग, हाउ मेनी आर फ्रॉम ECE, प्लीज मेंशन योर अटेंडेंस हियर। एक बार मुझे अटेंडेंस लगाओ बेटा। हाउ मेनी ऑफ आर, जितने लोग सेशन को देख रहे, जितने लोग सेशन को लाइक कर रहे, जितने लोग सेशन को देख रहे, तो प्लीज जो लोग सेशन को देख रहे हैं, ఎస్ ఎస్ మీ పేరు ఏంటి? నా పేరు సతీష్ మా, నా పేరు సతీష్. మన లాస్ట్ క్లాస్లో పైడి వచ్చాడా? లాస్ట్ క్లాస్లో పైడి అని అబ్బాయి వచ్చాడా? ఓకే ఓకే, చలో వాట్ ఇస్ ద ఆన్సర్ ఫర్ దిస్ క్వశ్చన్. కన్సిడర్ ద ఫాలోయింగ్, which of these form the part of the CPU. So what are the part of the CPU here? If you see, input device is a part of the CPU. No, input device is not a part of the CPU. Input device is not a part of the CPU. Next, main memory is not a part of the CPU. Next, auxiliary memory is not a part of the CPU. So control unit is a part of the CPU, arithmetic logic unit is a part of the CPU, and active hub to register set. So 2, 3 and 6, 2, 3 and 5 cannot be, 2, 3 and 6, 2, 3, 6. Okay, yeah. अभी 2 वाटमीटर मेथड पढ़ रहा था, CC हो गया सर, थैंक यू थैंक यू. कैसे हो सिग्मा? सिग्मा कहाँ से हो भैया? और कॉन्सेप्ट्स क्लियर हो गया? बहुत बढ़िया, आपको पूरा क्लैरिटी आ गया इलेक्ट्रिकल मेजरमेंट्स में? जी 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 जी, यस सर यस सर. नमस्कार नमस्कार, जितने लोग लाइव में देख रहे हैं मुझे एक बार आपका बैकग्राउंड बताइए बेटा, आपका प्रिपरेशन कैसा चल रहा है? आपका EC है ना, आपका EC का बैकग्राउंड कैसा चल रहा है? हाउ फार यू आर गुड इन दी सब्जेक्ट COA, हाउ फार यू आर गुड इन दी सब्जेक्ट COA. आप पहले कंप्यूटर ऑर्गेनाइजेशन आर्किटेक्चर को कब तक पढ़ा है और वॉट एवर यू हैव स्टडीड, प्लीज लेट मी नो. ओके, चलो लेट अस गो फॉर द नेक्स्ट क्वेश्चन माय डियर. तो एक क्वेश्चन को आंसर करने की कोशिश करो बेटा. ESE 2003 का सवाल है, जल्दी से जल्दी कर लो बेटा, जल्दी से जल्दी कर लो, फटाफट फटाफट. असर्शन एंड रीजनिंग दिया है. असर्शन में क्या बोल रहे हैं? असर्शन में क्या बोल रहे हैं? असर्शन क्या है, रीजनिंग क्या है? reduce instruction set computers use pipelined control unit. Reasoning, pipelining reduces memory requirements of the programs. वेस्ट बंगाल से हूं, बढ़िया, नाइस. तो ऑल ऑफ यू प्लीज हैव माय टेलीग्राम ग्रुप, वो टेलीग्राम ग्रुप से ज्वाइन करो बेटा. ओके चलो. Assertion and reasoning, reduce instruction set computers use pipeline control unit. This is a true statement, definitely this is the true statement. Pipelining reduces memory requirements of programs. No, pipelining fastens the things. Pipeline fastens the things. Pipeline will be fasten. What pipeline does not guarantee memory का requirement less होगा, नहीं है. Pipeline will fast things because parallel processing करता है, parallel processing करता है pipelining. So this A is true but R is equal to false. Yes, perfect. So pipelining does not guarantee memory requirements. No, reduces की problem नहीं है. We cannot say it can reduce the memory program. It will not reduce the programs. Okay, चलो बेटा, let us go for the next question. Try to answer this question my dear, try to answer this question. What is the overall number of clock cycles per instruction CPI for a machine A for which the following performance measures were recorded when executing a set of benchmark programs, assuming the clock rate of CPU as 200 MHz and execution of 100 instructions. The instructions category is given as arithmetic logic instructions are 38, load and store instructions are 15, branch, this is branch instructions are 42, others instructions are 5, number of cycles per instructions for this is 1, number of cycles for this instruction is 3, number of cycles per instruction is 4, number of cycles per instruction is 5. तो जल्दी बताओ बेटा क्या होता है इसका. What is the overall number of clock cycles per instructions for a machine A for which the following performance measures were recorded? तो करके करना है, you have to do it and you have to let me know. Make it fast. कैसा करना है इसका आंसर? See here. First of all, what is mentioned here? Frequency is given. The clock frequency is given as how much? The frequency is given as 200 MHz. Frequency is given as 200 MHz. And the time period is equal to 1 by f. 1 by 200 into 10 power 6. 1 by 200 into 10 power 6. So how much this is? 1 by 200 into 10 power 6, that is coming as 5 nanoseconds. 5 into 10 power minus 3. Okay, that is going to become 5 nanoseconds. So let us take total 100 instructions. Number of cycles per instructions is 38, one cycle. Number of cycles per instruction, for one instruction, one cycle, there are 38 instructions. So there are 38 instructions. So the number of cycles, the total number of cycles कितना होगा here? 38 होगा. Next, here load and store instruction 15 instructions, number of cycles is 3 is equal to 3. So for one instruction 3, so for 15 instructions 45. So branch instruction percentage is 42, number of cycles per instruction is 4. So 42 into 4, 168. Number of cycles per instruction is 4. So 42 instructions are there, so it will become 168. Next, 5 instructions are others. So number of cycles per instruction is 5, so total is 25. So the total cycles कितना हो गया? काउंट करो. 5 plus 8 13 plus 5 18 plus 8 26, 2 plus 2 4 plus 6 10 plus 4 14 plus 3 17. So 276 हो रहा है. Total number of cycles is equal to 276. Number of instructions is equal to 100. So is asking the clock cycles per instructions. Overall means average CPI is asking, average clocks per instruction is asking. So total number of cycles 276 divided by total number of cycles, that is 100. So that is 2.76. So the right answer for this question is option A. Frequency की जरूरत ही नहीं है. बस कोमल पांडे कहाँ से हो? Yeah, option A is the right answer. 2.76 is the right answer, my dear, for this question. Try to answer this question, my dear. फटाफट. ESE 2016 का सवाल है, जल्दी से कर लो बेटा. आई एम एक्सपेक्टिंग द आंसर फ्रॉम यू. what is the answer for this question? I'm expecting the answer. A processor has 32-bit architecture. So let us take, each instruction is 1 word long. So instruction length is given as 32 bit. So this is the length of the instruction, my dear. The length of the instruction is given as how much? 32 bit. So length of the instruction is given as 32 bit. It has 64 registers. So the number of registers is how much? Number of registers is 64. Next, it supports 50 instructions. Number of instructions is 50. Number of instructions is 50. Okay, which have 2 register operands and 1 immediate operand. So the instruction contains opcode, register operand 1, register operand 2 and 1 immediate operand. So this is opcode. This is opcode. What we call this as opcode. This is register operand 1. This is the register operand 2, and this is the immediate operand. This is immediate operand. Okay. Chalo. Number of instructions is equal to 50. That means number of opcodes is also 50. Okay. ऐसा करना है क्वेश्चन को, एक एक पर्टिकुलर ब्लॉक को हम फिक्स करके जाना है. So number of instructions means number of opcodes. So number of instructions is 50 means number of opcodes is equal to 50. Then size of opcode क्या होगा? Size of opcode will be dash. So आपके पास कितना bits होना? Opcode का size कितना होना? आपके पास कितना bits होना? That will represent the size of the opcode. So 2 power n should be greater than or equal to 50. So n is equal to 5. If I take, it will become 32. If I take n is equal to 6, it will be matching. So n is equal to 6. N is equal to 6 satisfies, because n is equal to 6 means 2 power 6, 64. In the 64, maybe 50 will be used, 14 will be unused. Okay. So number of registers are 64. So number of bits required. So size of register kitna hoga? Same to same. Size of register. So size of register kitna hoga? So 2 power n should be greater than or equal to 64. So n is equal to 6. So ye bhi 6 हो गया. So पूरा 32 में 18 चले गया. So what is the size of the immediate? So if you see the size of the immediate operand, if you check, size of immediate if you check, 32 minus 6 plus 6 plus 6, 32 minus 18. So 32 minus 18, it will come around as what? 32 minus 18 will come around as 14. So 32 minus 18 will come around as 14. So 14 is the size of the immediate operand. So with 14, what is the total? How many numbers? The total numbers with 14 digits. 14 bit means total numbers with 14 bit will be what? 2 power 14. So 2 power 14 means how much, my dear? 2 power 14 means how much? 2 power 10, 1024. 1024 into 16. So it is going to become 16,384. So total numbers will be 16,384. But answer is not the 16,384. Question में क्या पूछा? Unsigned. So unsigned integer. So unsigned range, unsigned दिया है. So unsigned बोलो तो 02 होगा maximum, 02 positive. So how much? 02. So total should be 16,384 numbers. So it should be 02 16,383 होना है. Total should be how much? 02 16,383. So the right answer here is 16,383 is the right answer. 16,380 the right answer. जितने लोग लाइव में है एक बार समझ में आया नहीं आया? How many of you understood this? Komal Pandey, is it clear? 16,383 is the right answer for this particular question. This is a very good question, very tricky question. So the size of operand आपको आ गया, but the size of operand is not the question. Size of the operand is not the question, my dear. Size of the operand is not the question. Okay. Chalo. 16,383 is the right answer. Chalo. Let us go for next question. Answer this question. ESE 2017 का सवाल है. ESE 2017 का सवाल है, जल्दी से जल्दी आंसर कर लो बेटा। जितने लोग लाइव हैं मुझे वॉइस कंफर्मेशन कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर या नहीं। या व्हाट इज द आंसर? ए कैशे लाइन हैज 128 बाइट्स, द मेन मेमोरी हैज लेटेंसी 64 nanoseconds. See, generally this is the main memory, so this is the CPU. So every time whenever CPU requires something, it will go to the main memory. It will go to the main memory. Okay, so every time CPU takes from the main memory. So here in between we are having a cache. So suppose if the CPU gets from the cache, it will take from it, otherwise it will go to the main memory. Okay na? So most of all the things which are repeatedly taken, that will be taken by the CPU. Which are repeatedly required from the memory, they are stored in the cache. समझ में आपको? Cache is the fastest memory and nearest to the CPU. जो रिपीटेड रहते हैं ना इंस्ट्रक्शन, जो रिपीटेडली यूज होता है, वो पर्टिकुलर ब्लॉक कहाँ होगा? कैशे में होगा, मेन मेमोरी से लेके इधर लगाना है। ओके, ए कैशे लाइन हैज 128 बिट्स, द मेन मेमोरी हैज लेटेंसी 64 nanoseconds. सो मेन मेमोरी के लिए टाइम कितना हो गया? तो इज आस्किंग द टोटल टाइम ऑफ एक्सेस. सो टाइम ऑफ एक्सेस इज आस्किंग, total time of access is time of access for the main memory plus time of access for the cache. So if you see here what is mentioned, the main memory has a latency of 64 nanoseconds and bandwidth 1 gigabyte per second. Okay, so cache line has 128 bytes. So first of all the time taken for the main memory is 64 nanoseconds. So this is how much? This is 64 nanoseconds plus cache time कितना है? 1 gigabyte per second. So this is 1 gigabyte per second. 1 gigabyte per second. That means what? 1 gigabyte of the data is going to be for cache. 1 gigabyte of the data per second in 1 second. So for 1 byte, how much time it will take? For 1 byte, it will take 1 divided by 10 to the power of 9. That means 10 to the power of minus 9 seconds it will take. So आपके पास cache line is having how many bytes? 128 bytes. So for 128 bytes of cache, for 128 bytes of the cache, how much time it will take? 128 nanoseconds will be taken. So the cache time is equal to 128 nanoseconds. So पूरा मिला के कितना होगा? 192 nanoseconds आएगा. So the right answer for this question is equal to 192. एक बढ़िया क्वेश्चन है कुमार जी, समझ में आपको? समझ में आपको? So सुपर क्वेश्चन. जो हमको मेन मेमोरी में कैश में मिलता है, कैश से एडजस्ट करेंगे. जो हमको कैशे में नहीं मिलेगा उसको हमने कहाँ जाएंगे? हम मेन मेमोरी के पास जाएंगे. एनी डाउट्स? Any doubts you can ask me, my dear. క్లారిటీ ఆ గయా సార్? మీ డిజిటల్ ఎలక్ట్రానిక్స్ చెప్పనమ్మా, నేను COA మాత్రమే చెప్తాను. COA కంప్యూటర్ ఆర్గనైజేషన్ ఆర్కిటెక్చర్. మైక్రో ప్రాసెస్ చెప్పాను కదా ఆల్రెడీ, మైక్రో ప్రాసెస్ అండ్ కంప్యూటర్ ఆర్గనైజేషన్. 9 members are watching. Those who are watching, please introduce yourself. You are from where, which branch you are? Sigma Infinity, are you following my class? West Bengal से है. Sri Short Creator, are you following my class? चलो let us go for the next question. Try to answer this question. ये ESE 2016 का सवाल है. क्वेश्चन देखो ध्यान से, क्या पूछ रहे क्वेश्चन में? A computer system has a cache with access time 10 nanoseconds, a hit ratio of 80%. and average memory access time is 20 nanoseconds. Then what is the access time for physical memory? So average memory access time he has given 20 nanoseconds. Okay, so try to do this question, very good question, quality question. Okay, see here, this is the cache, this is the physical memory. Okay, so this is the CPU, sorry, this is the CPU. So here comes the cache, so this is the cache, and this is the memory, physical memory or main memory. So first it will try for the cache. If it finds in the cache, then it is called hit. It is called hit. For any byte, first it will check in the cache. अगर cache में find out किया ना, उसको हम hit बोलते हैं. अगर hit नहीं हो गया, suppose it is not hit, that is called miss. So for miss, immediately it will go for physical memory. So it won't go to the physical memory if it happened. Only for miss it will go to the physical memory. So there is a formula actually. The formula is average time of accessing the memory. Okay, average time of accessing the memory is given by h into time of access for cache plus 1 minus h into main memory minus cache, Tm plus Tc. So this is the formula. Actually, how this formula is derived, that also I can go, but derivation is not necessary. See, what is the total time taken? How many hits are happening to access the cache? Whenever your hitting is happening, for each hit there is access time for the cache. Yes. So h into Tc plus main memory को हो रहा है, but main memory को लेके होने के लिए पहले, when main memory is going to be accessed, when the miss happens. So what is the miss percentage? We have to take 1 minus hit, that is called the miss. So if you take 100% as a total ratio, in 100%, some percentage will be the hit ratio, some percentage will be the miss ratio. Some percentage will be the hit ratio, some percentage will be the miss ratio. So hit ratio into Tc and 1 minus h into Tm plus Tc. Why Tc again came here? Because first you will check in the cache na. Once you check in the cache, if it is not found, then you are going to the physical memory na. So suppose there are 100 things. Okay, so first one is 10 hits are happened, or 30 hits are happened, 70 hits are happened. So 70 hits cache. So for every hit it is taking certain time na. So that's why 70 hits into time of each cache, time taken for one cache access. Now remaining 30, before going to main memory, that 30 should be missed. That means 30 has to be checked with the cache also now first. So they have to check with the cache, then you have to go to this. That's why 30 Tm plus Tc aayega idhar. Okay, so what is the hit ratio he has given as how much? So see here, what is the answer he has given? A computer system has a cache with access time of 10 nanoseconds. Cache time is how much? 10 nanoseconds. Cache time is 10 nanoseconds. So this is 10 nanoseconds. Okay, and the hit ratio is 80%. 80 by 100, that means 0.8. This is 80 by 100, that is 0.8 plus 1 minus hit, 1 minus 0.8, 1 minus 0.8 into, this is Tm we don't know, cache time he has given as how much? 10 nanoseconds. So the total average time he has given as how much? 20 nanoseconds. So इसको simplify करें तो आपको ये answer आएगा बेटा. Okay, can you answer this question? 8 members are watching. Do you understand this formula? HTC plus 1 minus h into Tm plus Tc. So if you simplify, how much you are going to get? Please check it. So this is 8 nanoseconds. This is 20 nanoseconds. This is 8 nanoseconds plus this is 0.2 into Tm plus 10 nanoseconds. Okay. So 20 nanoseconds minus 8 nanoseconds, that will become 20 minus 8, that will become as 12 nanoseconds. 12 nanoseconds is equal to 0.2 into Tm plus 10 nanoseconds. Tm plus 10 nanoseconds. So 12 by 0.2, 12 divided by 0.2, that is going to become as 60 nanoseconds. Okay, Tm plus 10 nanoseconds. So the right answer is 50 nanoseconds. 60 minus 10, the right answer is coming as how much? 50 nanoseconds is the right answer. So the right answer for this question is 50 nanoseconds. How many of you understood this point? How many of you clear about this point? 50 nanoseconds. 30 kadra 50 वस्तुंदी. Psycho, oh psycho सावी, कहाँ से हो भैया? 30 या? Check चेंड ఒకసారి. Is it 30 or 50? थर्टी का 50 nanoseconds. The right answer is 50 nanoseconds. चलो ESE 2016 में आ चुका है. See the same model question we got in the ESE 2012 also. Try to answer this question. See here, what is given in this question? The access time of a cache memory is 100 nanoseconds and that of main memory is 1 picosecond. 80% of the memory requests are for read and others are for write. Hit ratio for read-only access is 0.9. A write-through procedure is used. The average access time of the system for both read and write request is dash. Try to answer this better. How to answer this? The access time of a cache memory is 100 nanoseconds. So same here, my dear. So this is the CPU. So this is the main memory. So this is the cache. So try to understand the things clearly. So this is the CPU. So this is the cache. So this is the main memory. The access time of a cache memory is 100 nanoseconds. The access time of a cache memory is 100 nanoseconds. So to access this cache memory, the TC is given as 100 nanoseconds. And that of main memory is 1 picosecond. See, if it is hit, fine. If it is miss, then it has to go to the main memory. So for main memory, the time of access is how much? 1 picosecond. 1 picosecond. 80% of the memory requests are for read and others are for write. Okay, for read 80%, 20% write. Hit ratio for read only access is 0.9. Write through procedure is used. Okay, the average access time for both read and write request is asking. Both read and write. So first let us take read. So what is the total average time? T average is equal to same formula previously, whatever the formula we have used, H into TC plus 1 minus H into cache time plus main memory time. So first read only let us take. For read only, what is the percentage? Hit ratio for read only access is 0.9. So 0.9 is a hit ratio. Time of cache is how much? The access time of a cache memory is 100 nanoseconds. So this is 100 nanoseconds. Okay, so please substitute and tell me. This is 1 minus 0.9. Cache time is 100 nanoseconds plus main memory time is 1 picosecond. 100 nanoseconds, and please do it.
नमस्ते, मैं राधा बोल रही
this is 1 picosecond. This is 1 picosecond. So 1 into 10 power minus 12. 1 into 10 power minus 12. This is 100 nanoseconds. 100 into 10 power minus 9. So if you write 10 power minus 9 only, 10 power minus 9 into 10 power minus 3, or nanoseconds if we convert, how much it is? Thousand nanoseconds. This is 1000 nanoseconds. Why? Because 1 pico na, so I can take 1000 nanoseconds. So if you simplify, how much we are going to get this one? So this is 0.9 into 100, 0.9 into 100, 90 plus 1 minus 0.9, that is 0.1 into 1000 and 100, 1100. So that means 110. So 90 plus 110. So that will become as 200. 200 for read. Both read and write request he asked. So for read, that is 200. Next for write, let us take. For write, if you take the cycle, so for write, how much it will be? So average time for write, I can take it as T average, I can take it as how much? HTC, same to same formula, plus 1 minus H into TC plus TM होगा. So hit ratio कितना है देखो. The access time of a cache memory 100 next, the mean 80% of the memory request are for read and others are write. So 80% are that, so 20% are write. Okay, hit ratio of read only access is 0.9. Hit ratio for read only access is 0.9. So 80% of the memory requests for both for read and others are. आंसर कितना आ रहा है इसका, चेक करके बताओ यार. टू 200 nanoseconds आ रहा है. The TM should be 0.01 nanoseconds. 0.01 ना. Okay. Sorry. कितना हो रहा है? 0.1 picosecond కదా. 1 picosecond means 1000 nanoseconds కదా. 1000 into 10 power 3. All right. Sorry. 0. Yes. So this is mistake we have done. So 100 plus ఎంతమా మెమరీ ఎంత వస్తుంది? 0.000. ఓకే 0.001 सॉरी 0.001 नैनोसेकंड्स. तो आंसर कितना आएगा अभी, उसको सिंप्लीफाई करके देखो. सो दैट विल बी व्हाट 0.9 into 100 plus 0.1 into 100.001. So that is coming as very less. 100 nanoseconds is coming na. It's coming as 100 nanoseconds. एक बार चेक करना है डाटा इनसफिशिएंसी. Sorry, this is microsecond. The printing mistake. This is printing mistake, my dear. Please note down, this is microsecond. This is microsecond. So now अब clear होगा. So microseconds को nanoseconds में convert कर लो. So this is 100 nanoseconds and this is 1 microsecond. 1 microsecond means how much I can take? 10 power minus 6 into 10 power minus 3 by 10 power minus 3, 1000. अभी clear हो गया ना? सही है. इसको माइक्रोसेकंड कर लो, इसको माइक्रोसेकंड कर लो. सो वी कैन नो इसको माइक्रोसेकंड्स कर लो यार, इसको माइक्रोसेकंड्स कर लो. अभी कितना आएगा? 200 नैनोसेकंड्स आएगा. 200 नैनोसेकंड्स आएगा. ओके ना. सो Here total access time is asking. Total access time means what? Total access time. Total access time कितना कैसे calculate करना? Total access time. Total access time. How to calculate time? So time for read cycles plus time for write cycles. Okay na? Time for read cycles, time for write cycles. 80% are read. So 80% of the time, ante 80 by 100, that means 0.8 of how much time it will take? 200 nanoseconds it will take. And remaining 20%, that is 0.2. So that will take how much time? That will take how much time? That will take how much time? So that is write to the memory. We are going to write to the memory. So we are not going to write into the cache, we are going to write into the memory. That is 1 microsecond, so that will become 1000 nanoseconds. So if you simplify this one, how much you are going to get? So 0.8 into 200 plus 0.8 into 200, that is 160, plus 0.2 into 1000, so that will become 360. So the right answer here is 360 nanoseconds. Dear student, we have to understand 80% are read, 20% are write. 80% you are going to read from the memory cache, but write will be always related to the memory only. So to access to the memory, the time taken is 1 microsecond. So 20% of the time will go for 1000 nanoseconds. Why? Because it is taking 1 microsecond. Remaining 80% only we are taking cache cycles. So the right answer is 360 nanoseconds is the right answer. Very good question. Why? Because for reading it is okay, cache, but for writing what we are going to do? We are not going to write anything into the cache. We are going to, CPU is going to write anything into the 80%. But this is a total access time I am calculating. See, this is the average time for the read operations from the cache. But we are not going to perform any write operations into the cache. Write operations are going to be done on the memory only. The access time of a cache memory is 100 nanoseconds and the main memory is 1 microseconds. 80% of the memory requests for read and others are for write. So read will be happening for cache. We are going to take from the cache, but write means you have to go to the main memory only. The CPU cannot write into the cache. The CPU is going to read from the main memory. Bit ratio for read only access is 0.9 and write through procedure is used. The average access time of the system for both read and write request is asking. Both read and write request 360 nanoseconds. Is it clear? Okay, 80% we have taken from the reading will take cache, writing will go to the main memory. Very good question. 360 nanoseconds is the right answer. Yeah, try to answer this question, my dear. ESE 2011 का सवाल है. ESE 2011 का सवाल है. जल्दी से जल्दी आंसर करने की कोशिश करो. The speed gained by an n segment pipeline executing m tasks. So actually there are non-pipelining. Let us take first let us take non-pipelining. Non-pipeline method, if you take, there are how many segments? N segments and m tasks. So the total time of non-pipelining will be number of segments into number of tasks. Now the same thing if I am going for pipelining, so the total time for pipelining, so first task will be done in n segments. So first task will be done in n segments. The next remaining task will be done with m-1 segments. So this is what the pipelining methodology. First performance will go by n segments. Okay, suppose if there are 3 segments, the first instruction will complete in 3 segments. The next instructions will be sequentially 4th segment, 5th segment, 6th segment, like that. Okay, so total time of pipelining is this, n plus m-1. So the speed up ratio is asking. The speed up ratio means time of pipelining by time of non-pipelining. So that will become n plus m-1 Time of non-pipelining by time of pipelining. Time of non-pipelining by time of pipelining. So that will be n plus m minus 1, n into m divided by n plus m minus. Okay, that's the answer. Is it clear? Yes, option B hoga. Very good question this is. Chalo, let us go for the next question. Answer this question. ESE 2002 का सवाल है, जल्दी से जल्दी आंसर कर लो बेटा. Yes. 𝐂𝐤𝐬𝐞, where are you from? May I know? You are from which district? We are from which location? Which branch? Are you my previous batch student है क्या? App live का student है? A microprocessor has 24 address lines and 32 data lines. If it uses 10 bits of opcode, then the size of its memory buffer register. See, memory, there are two registers, my dear, MAR and MDR. So try to understand what is the purpose of these two, MAR and MDR. Any idea of MAR and MDR? MAR and MDR. MDR is also called as MBR. MBR. So this is what we call as memory address register. This is what we call as memory data register. So this is memory address register. Okay. So this is what we call as memory data register or memory buffer register. Register or memory buffer. Okay, so see here, memory address represents the address lines, number of address lines. So this will represent the data lines. So in the question is very clearly given, A microprocessor has 24 address lanes, 32 data lanes. That's it. So the right answer is 32. Option C is the right answer. Yes, you are my Savi, you are my regular class student, right? Yeah. मैं पहचान लिया आपको. चलो. So let us go for the next question. Yeah. Can you answer this question? ESE 2004 का सवाल है. How was my classes, Savi? Have you enjoyed my previous classes? Data access and temporary stores data being transferred. Excellent beta. Super. ये समझ गया मैं याद रख गया, याद में आ गया. चलो, consider a hypothetical processor with largest instruction length being 32 bit and 16 registers R0 to R15. Processor supports only following instructions. So what is the maximum number of address pins on this processor? Nice to see you again, feeling happy. So answer this question. Answer please. So if you see this, consider a hypothetical processor with the largest instruction length being 32 bit. So instruction length is given as 32 bit. The size of the instruction is given as how much? 32 bit. So the size of the instruction given as 32 bit. Okay. Consider a hypothetical processor with largest instruction length being 32 bit and 16 registers R0 to R15. Processor supports only following instructions. 16 registers. Okay. So if you see first this one opcode, so it is what we call as opcode. So what is the size of the opcode? What is the size of opcode? So first, number of instructions you can find out. So what are the number of instructions? So if you see the number of instructions here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of instructions is given as 9. So number of opcodes also 9. Number of opcodes also 9. Then size of opcode kitna hoga? Size of opcode is equal to 2 power n should be greater than or equal to 9. So n will become 4. If I take n is equal to 3, n is coming as 8. 2 power n is coming as 8. Let us take n is equal to 4. So the size of the opcode is 4. So out of the total now 32 bit la 4 gone. So how many address field? These are all address field. Whether it is a register address field or whatever, the total is address field. So the total address field remaining is how much? 28. So 28 aayega. So that means 4 plus 28, 32 ho raha hai. So the number of address pins required here is how much? 28. Option B is the right answer. Option B is 28 is the right answer. Sure. Let us go for the next question. Is it clear, Savi? Any doubts here? See, of course, number of registers is 16. इसमें एक होगा register field. In this one may be the register field. In this one may be the register field. The register field will take 4 bits. But total together is address field. Total together is address field. Na? So out of this 28, 4 bits will go for registers. So overall 32 bit is the instruction size. इसमें opcode का size 4 चले गया. 4 चले गए तो हमको कितना मिल रहा है? 28 मिल रहा है. So 28 में register field होगा, लेकिन पूरा address pins कितना हो रहा है? Address field के लिए dedicated pins होता है address pins. So 28 bits होता है. So 28 bits means 28 pins. Is it clear? Any doubts? Hope I understood. All of you understood? Savi? The number of instructions is given, from that also you can do it. Chalo. There is no other way to do it. Chalo. Try to answer this question. ESE 2011 का सवाल है. List 1 and list 2. DMA IO, cache, interrupt IO, condition code registers, high speed RAM, disk printer ALU. Answer please. Yeah. See here, we know very well that DMA IO, cache, interrupt IO, condition registers. Condition registers is related to arithmetic logic unit. When you perform some operations, carry flag, parity flag, zero flag, so they will be condition. Okay. Next. Cache is always high speed RAM, that's fine. Okay. DMA is related to hard disk and interrupt is related to printer. So A goes to 2, B goes to 1. So right answer is option B is the right answer, my dear. Chalo, let us go for the next question. Try to answer this question. ESE 2022 का सवाल है. ESE 2022 का सवाल है. जल्दी से जल्दी आंसर कर लो बेटा. Answer please. Sir, interrupt IO explain once. Okay, okay. Previous wala. Yes, yes. Just wait. This one you're asking. See, DMA means direct memory access. Generally, disk means hard disk. So this hard disk will be having bulk data. To transfer the bulk data, I cannot choose interrupt IO because it is slower. Bulk data means at a time bulk of the data has to go to the direct memory. Next, cache is a high speed that you know. Interrupt IO, printer में है कैसा है? Printer का operation कैसा रहता है? So when you connect the printer to our CPU, you will get a pop-up at the bottom. At the bottom you will get a pop-up, a new device has been found. Printer is a slow device. Then I am giving a control P, then line by line printing will happen. So every time when a line by line print is over, the printer will give acknowledge interrupt to this fellow, processor will understand, it will go to the next line. So like that the paper will be printed. Is it clear? So that's why printer is a slow device. So it definitely requires every time an interrupt. Okay, chalo. Let us go for this question. Yeah, answer this question my dear. This question answer कर लो. ESE 2022 का सवाल है. Okay Xavi, very bright picture रहा. Very simple question. These type of questions, many things we have done. A, okay, let us see. With the memory chip size, so let us take a memory chip size like this. So generally memory is represented like this, where N represents the number of address lines, M represents the number of data lines. Okay, a memory chip size is 1024 into 1. That means 2 power 10 into 1. Number of address lines is 10 and number of data lines is 1. Then the number of memory chips needed. So how many number of that chips are needed to design how much memory? To design 8 kilobytes of memory. 8 KB memory. So how to represent this? N is equal to 8 kilobyte divided by 2 power 10 into 1. 8 kilo means 2 power 3 into 2 power 10, and this is byte 8. So this is 2 power 10 into 1. That means 2 power 13 divided by 2 power 10 into 8. And 2 power 13 minus 2 power 10, 2 power 3, 2 power 3 into 8, 2 power 3 into 8, 8 into 8, 64. So I need 64 number of chips. Option C vastundi kada KK. Option C is the right answer na. Option C is the right answer, right? 64 is the right answer, right? What happened? Am I right or not? 64 is the right answer, Kumar. ये कैसा आ गया? हाँ, चलो लाइक टू आंसर दिस क्वेश्चन माय डियर. ESE 2022 का सवाल है. ESE 2022 का सवाल है. जल्दी से जल्दी आंसर करने की कोशिश करो. The most personal computers compatible computer system use 20-bit address code to identify each of over 1 million memory locations. What is the 5-digit hexadecimal address of the 500th memory location? Answer please. See, he is asking the 500th memory location. So if you take the table, the first actually starts from where? This is the first memory location. So first memory location start from 0 0 0 na. Okay, so he's asking 500th memory location means this will be 0499 na. Am I right or not? This is first memory location, this is 500 memory location. Am I right or not? Any doubts in this? In digital we are having like that. No sir, class lo unna sir, cheppandi parలేదు plan cheppandi అంటే మీ ప్లాన్ ఏంటి? ఏం లేదు, అది అన్నం పెట్టుకుంటా లేకుంటే మీరు చెప్పిన వెజ్ కర్రీ అంటే వాళ్ళు సార్ వాళ్ళు వస్తురా? సరే వస్తానండి, 8:30కి వస్తా. 8:30కి అయిపోతుంది క్లాస్. రైట్ అన్న, రైట్. చలో, the most personal computers, see, do you understand? ఇది 500th memory location. 500th memory location అంటే 0 to 490 అంతే కదా. సపోజ్ యూఆర్ హ్యావింగ్ 14 నెంబర్స్. 14 నెంబర్స్ అంటే వాట్? 0 to 13. You understand? In digital. So that's the point you have to understand. So 500th memory location అంటే 0 to 499. So we have to convert 499 into hexadecimal. So that is a confusing part here. That is a confusing part. Not 500 into, so 16 2 ja 32, 16 3 ja 48, 16 1 ja 16, so this is 3, 16 1 ja 16, so this is 15. So 1F3, right answer is 1F3. Many students will confuse 1F4, but not that. 1F3 is the right answer. Do you agree? Any doubts here? Psycho Savi psycho na nuvu? Okay. Kumar KK, KK, is it right or not? Do you understand? ఇక్కడ 500th మెమరీ లొకేషన్ అడిగాడు. 500th మెమరీ లొకేషన్ అంటే ఏం తీసుకోవాలి మనం? 0 to 499 అని తీసుకోవాలి. అప్పుడు ఇది ఫస్ట్ అవుతుంది, ఇది 500 అవుతుంది. అర్థమైందా? సమజ్మే? దిస్ విల్ బి 0 to 499, సో టోటల్ విల్ బి 500. 0 to 500 కదా, 0 to 499 తీసుకోవాలి. నువ్వు ఒకవేళ 0 to 500 తీసుకున్నావు అనుకో, అది 501 లొకేషన్ అవుతుంది డిజిటల్. దట్ ఇస్ ద పాయింట్ యూ హావ్ టు అండర్స్టాండ్. 0 0 1F3 is the right answer. Savi, is it clear? But by mistake, suppose if you take 500 na, by mistake if you take 500, suppose 16 1 ja 16 3 ja 48, 2 వస్తుంది, 16 1 ja 16, 4 వస్తుంది. So 16 1 ja 16, so this F వస్తుంది. So 1F4 వస్తుంది. But 1F4 is wrong. We have to take 1F3 because we have to take for 0 rest. And the first is here to confuse us, nothing to use. Nothing to use. Easy but tricky one. Yeah, my bowl round. So very tricky, but confuse करने के लिए हमको F4. This is F5. Okay, this is F5. F4 it should. Okay. So right answer is F3. So let us go for the next question. Answer this ma. ESE 2015 का सवाल है. Memory management is a very very good topic. इसमें बहुत सारा questions आ गया. First sentence. bit address ante it should be 5 digits. 20-bit address ante 5 digits ma. 20-bit address means 5 digits. Ante ela ostante like this 0 0 0 0 0 0 4 9 ostadi. 20-bit kada. 20-bit means A0 to A19. 20-bit means A0 to A19. So A0 to A0, A1, A2, A3 oka size. Next A4, A5, A6, A7 oka set. A8, A9, A10 one set. Like that it will go on. Okay na? See here A0 to A0, A1, A2, A3 ఇది ఒక సెట్. A4, A5, A6, A7 ఇది ఇంకొక సెట్. A8, A9, A10, A11 ఇది వన్ సెట్. A12, A13, A14, A15 ఇంకొక సెట్. A16, A17, A18, A9. 20-bit address అప్పుడు ఎంత వస్తుంది? సో దిస్ ఈజ్ 1 0, దిస్ ఈజ్ 1 0, దిస్ ఈజ్ 1 0, దిస్ ఈజ్ 1 0, దిస్ 1 5 zeros వస్తుంది. 1 2 3 4 5. అట్లనే 00499. That's why 001F3. Okay va? Okay va? Generally 8086 microprocessor will have 20 address lines. 8086 microprocessor will be having 20 address lines. 20 address lines ante 2 power 20 memory locations. 2 power 20 memory locations ante 1 megabyte. 1 megabyte. అర్థమైందా? సైకోసావి in Telugu అర్థమైందా means समझ गया है, समझ में आया नहीं? Do you understand or not? Do you understand or not? In Telugu language we call as అర్థమైందా, అర్థమైందా రజా. Yeah, let us go for one more question. Answer this question. ESE 2015. 4 memory chips of 16:4 sizes have their address buses connected together. The system will be of size dash. ESE 2015 का सवाल है. आंसर कितना होगा? ऑप्शन सी होगा. वेरी गुड, ऑप्शन सी इज राइट आंसर. Why? Because 4 memory chips of 16x4 size. See, one chip like this. But very good question. 16x4. 16x4 means 2 power 4 cross 4. So 4 is the number of address lines and 4 is the number of data lines here. So this n is equal to 4 here. Next, another chip. Like that, ఎన్ని ఇచ్చాడు ఇక్కడ? ఎన్ని చిప్స్ ఇచ్చాడు? 4. Okay, 4 chips. So there are 4 chips. Chip number 1, chip number 2, chip number 3, chip number 4. Okay na? 4 chips are there. 16x4 size. So 4 address lines. So all are 4 address lines. 4 address lines. ఎందుకు 4? 16x4 కదా. 16x4 means 2 power 4 cross 4. ఇలా రాసుకోవాలి. 2 power 4 cross 4. Yeah. So 2 power 4 cross 4. So this is 2 power 4 cross 4. This is 2 power 4 cross 4. This is 2 power 4 cross 4. So these are the data lines. So these are the data lines. So these data lines are 4. This is 4. This is 4. This is 4. So what is telling now? 4 memory chips of 16x4 size have their address buses connected together. So these all address buses are connected together. So all address buses are connected together. All address buses are connected together. All address buses are connected together. అప్పుడు ఏమవుతుందమ్మా? So all the address buses are connected together. So total address line 16 అలా ఉంటుంది. So this data lines will be 16x16. So what is the right answer? So now what happens? Everything is connected. 16 will be like that only, and Yeah. So total data lines, if you check the total data, so 4 plus 4 plus 4, so that will become 16. Right answer is 16. Yes, data lines width will be changing. Total memory chip will be like that. Chalo, let us go for the next question. Can you answer this question? ESE 2000 का सवाल है, programming related question. Try to answer this question. Answer please. Option C है. Okay, let us see here what is going to happen. This is load x. Okay, x. Load x means x I am taking. Multi y. Multi with y. So that will become x into y. Next, store t1. Store t1. Ante t1 is equal to xy. Okay, multi t1 ante t1 into t1, that will become xy whole square. Store t1 again. Okay, again t1 is equal to xy whole square. Load z. Okay, load z. Okay, add y. Add y ante z plus y. Next, add t1. So xy whole square plus z plus y. Store r. So r is equal to xy whole square plus y plus z. Option C is the right answer. This is what plus or minus are wrong. Done. Very good. Option C is the right answer. Okay, let us go for one more question. Answer this question, my dear. ESE 2023 का सवाल है. Latest questions बेटा. 𝐂𝐨𝐬𝐞. These questions are latest. What is the number of bits in the main memory address for a memory system having the following specification? Size of the main memory is 4 kilo blocks, size of the cache is 128 blocks, and the block size is 16 words. Try to answer this question, my dear. Answer please. Answer option B or A. Okay, let us see here. What is the number of bits in the main memory address for a memory system having the following specification? Size of the main memory is 4K blocks. So let us take this as a main memory. So this is a main memory. So this is one block. This is block 0. Like this, it is having how many blocks? The total size 4K blocks. 4K blocks. Next, size of the cache. Cache will be here. So size of the cache is, so this is one block. This is one block. This is one block. So it is having 128 blocks. 128 blocks. This is cache. This is main memory. Okay, and the block size is 16 words. So one block size is how much? 16 words. So 4K blocks. The 4K into 16 words. Ante 2 power 2 into 2 power 10 into 2 power 4 words. Because the minimum size is word here, so that become as 2 power 10, 2 power 16 words. 2 power 16 words. So if you see, this information is nothing, because question asked is, what is the question asked here? The question asked is, what is the number of bits in the main memory address? Main memory address. So the bits are how many? 16. So the right answer is 16 na beta. Why you have gone for option C or option B? मुझे समझ नहीं आया साइका. ये पायल कैसे हो? चलो. Why you gone for that? Question asked is for, assume that the system uses set associative mapping with 4 blocks per set. एक सेट को 4 ब्लॉक्स है, 4K ब्लॉक्स है ना, मेमोरी का देखना है कि वाई यू आर गॉन फॉर कैश मेमोरी. ओके, सो दिस इज 15. ओके, 16 होगा. 2 + 10, 12 + 4, 16 होगा ना. मिनिमम साइज इज वर्ड. ओके, दैट्स इट. 4K blocks. This is block 0. Each block is having 16 words. Each block is having 16 words. So this is word 0, this is word 1, like that. So block 0 is having 16 words. 16 words. So this is word 0, this is word 1, this is word 15, like that. 0 to 15, 16 words. So word another common. Word another common. So total how many bits are required? 2 power 2, 2 power 10, 2 power 4. 2 + 10, 12 + 4, 16. So are we clear? So why you have gone for 24? We don't consider the cache. Question asked is about the main memory. देखो, question में clearly mention किया है main memory. What is the number of bits in the main memory address? Got it? Any doubts? एनी डाउट्स बेटा? कंफ्यूज किया हमको? कंफ्यूज किया? एक्चुअली क्वेश्चन में बहुत पूछा, लेकिन क्वेश्चन में मेन मेमोरी के बारे में पूछ रहे हैं. आंसर इज 16 माय डियर. ओके, आंसर दिस क्वेश्चन. ESE 2014 का सवाल है, जल्दी आंसर कर लो बेटा. द सेमीकंडक्टर रैम ऑफ अ डिजिटल कंप्यूटर हैज व्हाट हैपेंड? नो रिस्पॉन्स. यू अंडरस्टैंड और नॉट सावी? The semiconductor RAM of a digital computer has a word length of 16 bits and a capacity of 65,536 words. Okay, it has cycle time of 80 nanoseconds. If the CPU is much faster than the memory, the time required to fill 1025 bytes of this memory with all zeros will be dash. With all zeros will be dash. All zeros will be dash. Please answer this question. Very good question. कितना आ रहा है आंसर? A semiconductor RAM of a digital computer has a word length of 16 bits. Okay, one word is equal to how many bits? 16 bits. One word is given as 16 bits and capacity of 65,536 words. If the CPU is much faster than the memory, the time required to fill 1024 bytes memory. Okay. See here, what is the meaning of this now? I have a CPU here, I have a memory here. So this is CPU, this is memory. This memory, a semiconductor RAM as a digital computer has a word length of 16 bits. So it is having 65,536 words. So this is word 0. So this is word 0. This is word 1, word 2, like that. It is having how many words? So this is 0th word. This is 65,535 word. Okay. Cycle time of 80 nanoseconds. If the CPU is much faster than the memory, the time required to fill 1024 bytes of this memory with all zeros. 1024 bytes. 1024 bytes means how many words first? See, 1024 bytes means how many words? Because memory is categorized in the form of words na Savi. Memory is categorized in the form of words. So he is telling that the time required to fill 1024 bytes, first convert into words. One word is equal to 16 bit na. One word is equal to 16 bits. So 1024 bytes means how many words? 1024 bytes means how many words? One 1024 bytes means how many words? Okay. Cheppandamma, how many? Yes, 512. It will be 512 words. 1024 into 8. Okay. Divided by 16. 512 words. Okay. So cycle time of 80 nanoseconds. So for one word filling, so this is one word. So to fill 0 here, it takes a time of 80 nanoseconds. So for one word access, 80 nanoseconds. So for 512 words, how much? 512 into 80 nanoseconds. So कितना आ रहा है? चेक करो बेटा, कितना आ रहा है? 512 into 80 nanoseconds. 16, 8, 9, 40, 40.49 4096 4096 nanoseconds. 40,960 and option A is the right answer, right? Option A 40.96 kada Kumar, option A is the right answer. See, one word is equal to 2 bytes. One word is equal to 2 byte. 1 byte is equal to 1 by 2 word. So divide by 2 करो आपको आएगा. See, one word is equal to 2 bytes. So 1 byte is equal to 1 by 2 words. So 1024 bytes is equal to 1 by 2 into 1024. It will come as 512. Is it clear, Savi? समझ गया? मिस्टेक कहाँ की आपने? One word is equal to 2 bytes. 1 byte is equal to half word. One word is equal to 2 bytes. Word under 16 bits kada. 1 byte means 8 bits. One word is equal to 2 bytes. So 1 byte means half word. So 1024 bytes means 1 byte into 1024 words. Very good question. So let us go for next question, my dear. Answer this question. ESE 2002 का सवाल है. He has given here. I think is it visible clearly? Yeah, clearly visible. हाँ. CSC के लिए थोड़ा कॉम्प्लिकेटेड रहता भैया, लेकिन आप प्रैक्टिस के लिए यूज कर सकते हैं. ये EC के लिए है. EC के लिए इतना डेप्थ नहीं होगा, CSC का डेप्थ नहीं होगा. Answer please. Okay, see here. Start. He has given the flow chart. A is equal to 5, B is equal to 15, X is equal to 10, Y is equal to 20, Z is equal to A plus B. A plus B means 5 plus 15. So 5 plus 15 means 20. Next, M is equal to X into Y. M is equal to X into Y, that is 10 into 20. So that becomes 200. Next, A is equal to A minus B. A is equal to A minus B. A minus B into 5 minus 15. That means minus 10. X is equal to X is equal to X into Y. X into Y. 10 into 20. That is 200. B is equal to A plus B. B is equal to A plus B. And only 5 plus 15, 20. Y is equal to A into B. Okay. Acha, A is equal to minus 10. Sorry, నేను మిస్టేక్ చేస్తున్నా ఇక్కడ. ఏదో మిస్టేక్ జరుగుతుంది నాకు అర్థమైంది. ఏదో రాంగ్ చేస్తున్నా. ఒకసారి జాగ్రత్తగా వెళ్దాం. ఏదో లింక్ ఉన్నట్టుంది. I think there is a link. A is equal to 5, B is equal to 15, X is equal to 10. A is equal to 5, b is equal to 15, x is equal to 10, y is equal to 20, z is equal to a plus b, z is equal to a plus b 20, m is equal to x into y, that is 200. Next, a is equal to a minus b, a is equal to a minus b, 5 minus 15 and minus 10, x is equal to x into y అంటే 200. b is equal to a plus b, ఇక్కడ వస్తుంది చూడు, a అంటే minus 10, b అంతా 15, minus 10 plus 15 అంటే 5 అవుతుంది. y is equal to a into b, a is equal to minus 10, b is equal to 5, it is minus 50. Next, y is equal to x plus y, y is equal to x plus y, already y minus 50 ఉంది, plus x ఎంత 200, 200 minus 50, that is 150. Next, a is equal to b minus a, b ఎంత 5 minus a ఎంత minus 10, 15. ఇప్పుడు ప్రింట్ a b x y, సో a వచ్చేసి 15, b వచ్చేసి 5, x వచ్చేసి x 200, y 150. Answer. I am not talking Telugu bhaiya, just middle I am using some Telugu ante. Cheppandi ikkada 15/5, what happened? 15 and 5, right answer is option D. Deepak Verma, I am not using Telugu as a full language, just some of the students are Telugu, that's why बीच में कुछ Telugu use किया भाई, Telugu language नहीं. 15 and 5 is right answer ना. चलो let us go for next question. आंसर दिस क्वेश्चन ESE 2010 का सवाल है, ESE 2010 का सवाल है बेटा. चलो, given that the main memory access, whenever this question is given, you please take this diagram always. Please take this diagram. This is my CPU, this is my cache, this is my main memory. First CPU ekkadiki veltadi, first CPU will go to the cache. If it is found in the cache, then it is called hit. Suppose in the cache it is not found, then it is called miss. Then only it will go to the main memory. That means the time of access for hit is only this, the time of access for cache is this, but time of access for the main memory kante mundu time of access plus this we have to do. So hit time is only this time, but miss time here and here it is going na, so both we have to consider. So the total average time is taken as hit ratio into access time for cache plus 1 minus hit ratio into access time for cache plus access time for memory. That is the formula. This is the formula actually. Given that the main memory access time is 1200 nanoseconds and the cache access time is 100 nanoseconds, the average memory access time is not exceeded 120 nanoseconds. Okay, the hit ratio is asking. So average time వచ్చేసి 120 nanoseconds exceed అవ్వకూడదు, hit time తెలియదు, time of access cache access time is given as 100 nanoseconds, this is 100, this is 1 minus h, cache ఇచ్చేసి 100, time of access for main memory is how much? Main memory access 200 nanoseconds. So ఇంత వస్తుందమ్మా, please find out. 1300, how much can you calculate? Tell me how much it is coming, can you calculate and tell me? So this is 100h 1 minus h, please simplify and tell me. 1300 कितना आ रहा है? Find out the h value. h value कितना आ रहा है? जल्दी बताओ यार. Savi, do you understand this formula? You understand this formula? The total average time and the total average time is equal to time of access for the cache. Time of access for the cache is equal to hit ratio into cache access time plus miss ratio. But whenever miss ratio is happening, first you are adding to cache. You are checking in the cache. If it is not found, then you are going now. That's why the time should be accessed for cache as well as memory. That many times. Okay. So now, what is the formula? This is 120. Simplify cheyandra naina. Simplify je cheppura. Kumar. H value how much is coming? Option B RA. Sure. Okay. I'm taking granted. Simplify karke putta. 98%. 0.98 will come as a ratio. This formula is clear. See, first time going here, I found. So that has taken me some TC. Second time I am going, found. TC, 2 TC, 3 TC, 4 TC, 5 TC, 6 TC, 7 TC. So 98 times I found. 98 times I found. Next 99 times I miss. So miss means again you have access to cache. So that time also you have to consider. 98th time also you have access, then you have gone for this. Next 100th one, 102 times. Out of 100, 98 times you are going to cache, 2 times you are missing the cache, then you are going to main memory. Ante you should consider the cache time and also main memory time. Because before going to main memory, you will access the cache. First you will check in the cache. And you have to consider this time also cache access time. Cache के पास जा रहे, उसमें check कर रहे, नहीं है, then main memory के पास जा रहे. So main memory का total time calculation में ये time consider करना, ये time भी consider करना. That's why TC plus TM. लेकिन कितने बार उधर जाएगा उधर? कितने बार अपने main memory के पास जाएगा? Out of 100, how many you missed from cache? उसको हम बोलते हैं miss ratio बोलते हैं. So this is called hit ratio. This is called miss ratio. If hit ratio is 100%, 100 में 1 minus h बोलते 100% में कितना दे रहे? समझ में आपको बेटा? Hit ratio, miss ratio. So answer is 98% is the right answer. Got it clear बेटा? चलो. Enjoy the session. Beautiful session. Can you answer this question? ESE 2020 का सवाल है, जल्दी कर लो बेटा. The hexadecimal of binary number. So hexadecimal of binary number 1101. Next 00112. In hexadecimal he is asking. So in hexadecimal means what to do? So this is 3. This is A10 B11 8 plus 4. A10 B11 C12 D13. So this is D and this is 316. The right answer is D316. मजा आ गया? ऑप्शन ये कदा? ऑप्शन ए इज राइट आंसर. हेक्साडेसिमल को पता है ना? A is equal to 1010, B is equal to 1011, C is equal to 1100, D is equal to 1101, E is equal to 1110, F is equal to 111. But got it up? चलो D3 या yes or no? चलो आंसर दिस क्वेश्चन. ESE 2019 का सवाल है. नंबर सिस्टम्स. कन्वर्ट डेसिमल 41.687 in decimal, convert to binary. I hope you can do it. Make it fast better. आंसर ऑप्शन। हाय रोहन, कैसे हो? नमस्कार नमस्कार रोहन, कैसे हो? ऑप्शन सी आ रहा है। चलो, रोहन फ्रॉम इंस्ट्रूमेंटेशन, राइट? 41 to decimal, so 41 to 20 ja 41 to 10 0 to 5 0 to 2 ja 4 1 to 1 ja 2 0 to 0 ja. So here 41 in decimal I can take it as this is 1 0 1 0 0 1. So this is a binary. Okay. 0 1 0 1 0 1 0 1 0 1 0 1 double 0 1 2. Next 0.6875 0.6875 into 2 कितना आ रहा है एक बार चेक कर लो। 0.6875 into 2 0.6875 into 2 is coming around 1.375. Next 0.375 into 2 0.3 2 0.75 0.75 into 2 1.5 0.5 into 2, that is 1.0. So take this 1011, so 0.101. Okay, that means answer is 101,001.101. Option is right. Yes, समझ गया? कहाँ हो आप? डी या इज इट ऑप्शन डी और ऑप्शन सी? ऑप्शन सी है ना? ऑप्शन सी है ना बेटा? Option, yeah. See, some of the questions, general questions, what is the answer? Which one of the following buses was designed to improve bandwidth and decrease latency in computer systems? PCI bus, VESA bus, ESE bus, ISA bus. These are some buses. Yes, working as a project associate at IIT Roorkee. Sir, ESE weightage ఏ పెట్టలేదా? పెడతానమ్మా, పెడతా, దొరకట్లేదు నాకు స్లైడ్. 20 క్వశ్చన్స్ వచ్చినాయి, పెడతా స్లైడ్ పెడతా. వెరీ గుడ్, ఎక్సలెంట్, వెరీ గుడ్ రోహన్, హౌ ఆర్ యూ? నైస్ టు సీ యూ, nice to see you. You are from instrumentation last year, so please share your feedback yaar. I'm very happy to see you in IIT Roorkee. Is one of my सावी देखो मेरा स्टूडेंट आ गया YouTube में, बहुत अच्छा स्टूडेंट है रोहन, as one of the finest student from instrumentation. He used to attend instrumentation all classes, each and every class he used to attend. Even the strength is very less instrumentation, एक पेड क्लास में हर दिन मेरा पेड क्लास में एक ही बच्चा 2 बच्चा रहता था, उसमें रोहन का नाम सुनता था मैंने, हाँ, इंस्ट्रूमेंटेशन का बच्चा. See, PCI, these are the peripheral component interconnect. See, please note down, these are general science bits. This is computer networks bits. Peripheral component interconnect. Peripheral component interconnect. So, which is the most fastest bus? Okay. So, VSI is something different, that is related to Video Electronics Standard Association bus. This is Video Electronics. So, Video Electronics Standard Association bus. Okay. Industrial standard architecture. This is industry standard architecture. Industry standard architecture. This is extended industry standard architecture. Industry. Out of all these, PCI is the most fastest beta. That is a general question asked. That is a general question asked. Okay, congratulations Rohan, nice. Which project you are doing? May I know which project you are doing? Answer this question. ESE 2022 का सवाल है. Which one of the following methods is used when the processor issues an IO command, continues to execute other instructions, and is interrupted by the IO module when the latter has completed its work? Interrupt driven IO, IO device controller, IO channel processor controller, programmed IO. Try to answer this question here. Which one of the following methods is used when the processor issues an IO command, continues to execute other instructions, and is interrupted by the IO module when the latter has completed its work? Yes. What is the answer for this question? Which one of the following methods is used when the processor issues an IO command, continues to execute other instructions, and is interrupted by the IO module? Yes, the right answer is interrupt driven IO. Interrupt driven IO. Okay. Whenever interrupt is interrupted means interrupt driven IO. That's it. Answer this question. देखो बेटा, लेटेस्ट क्वेश्चन सावी, the questions are latest question. ESE 2024 में question last year. Which one of the following is used to increase the performance of CPU? That means executing more instructions in less time. It is a kind of product used to measure the physical parameters of the human body. It's a biomedical project, beta. Biomedical project. Are you preparing for IES or what? Are you preparing for IES? Pipelining. Very simple question. देखो कितना easy question आ गया ESE 2024 में. Yeah, it's a biomedical instrumentation. So you are using biomedical sensors. Okay. Answer this question. ESE 2024 का सवाल है. Root hub. This question is related to computer network, CN. Root hub. Generally in our internet connections, we'll use this. Consider the following functions of a root hub. It performs power distribution to the devices. It enables and disables the ports. It reports status of each port to the user. ESE 2024 का सवाल है. Root hub generally networks will use. The right answer is all this. It performs a power distribution. Generally routers. So this is a root hub now. So what the root hub will do, will connect the multiple devices. Connect the multiple devices like this. Okay, root hub. So it performs power distribution devices. It enables and disables the ports. It reports status of each port to the user. Yes, all are correct. All are correct. RH. This is a root hub. So let us go for next question. See, this question answer ESE 2020 का सवाल है. Try to answer. Which one of the following is a powerful web platform? Powerful web platform for web applications and web services, built-in virtualization technologies, variety of new security tools, enhancements, and streamlined configuration and management tools. Option A, Internet Explorer. Option B, IIS. Option C, Web Matrix. Option D, Web App Developer. It's a computer networks question, my dear. So here this question is related to internet technologies. So this is IIS. The right answer is Internet Information Services. In your system also you can check IIS tool will be there. Powerful web platform for web application, web services, built-in virtualization technologies. Information services, Internet Information Services, you can check it. In your computer also you can check the IIS. In your settings you can go and you can check it. Internet options flow you can set, you can select the internet options flow, you can select IIS. Okay, that's it, my dear. With this I am closing. See here, this question ESE 2019 का सवाल है. High level programming languages preferred by the scientific community as they are user friendly. High level programming languages provide ways of detailing instruction for problem solving that are translated into low level language via compilers and interpreters before executing by the computer. Yeah, you can answer this question, GK question. So Rohan, I am very happy to see you, beta. Are you getting any stipend? Are you getting any stipend, Rohan? IIMT Roorkee. Very good, very good, very good. Project associate. So after this project, what will happen? We will have a permanent job, or again you have to write again any exam? आपका MTech हो चुका है, वही MTech and research कर रहे हैं अभी. ये प्रोजेक्ट होने के बाद उसके बाद क्या करना है? प्रोजेक्ट का ड्यूरेशन कितना होगा? 2 साल और 1 साल. उसके बाद आप फिर से जॉब करना पड़ता है क्या? High level programming language preferred by the scientific community as they are user friendly. Why they are user friendly? High level programming language provide ways of detailing instruction for problem solving that are translated into low level language via compilers and interpreters before being executed by the computer. Yes, both the statements perfect. That's why they are using. No, they both. Sorry, I have given right this one. Na? Correct only, na? Most of all the people, why you are going for B? Most of all the people are using this. Actually, user friendly. Why user friendly? It is explaining the reason. It is explaining the reason of user friendly. It is explaining the reason of user friendly, beta. It is explaining the reason of user friendly. It is explaining the reason of user friendly. Why it is user friendly? Problem solving translated to low level language. Perfectly matching, na? Why you have gone for option B? Rohan, I am asking you, are you there? Yeah. This is research associate, na? Research associate means after some time duration again the job will be there, or again you have to try for another job. Please focus on your GATE score also, okay? आपने MTech complete हो चुका है? चलो. Thank you, my dear. This question can you answer? ESE 2022 last question. Which one of the following provides an interface to which a client can send a request to perform an action? In response, the server executes the action and sends back the result to the client. It is called file server system, open source system, computer server system, peer-to-peer system. Try to answer this, my dear. Yes. Sir, EEE PDF ekkada provide chestaru? I don't know, yaar. I think it will be available in the. See, it's not peer-to-peer, my dear. Peer-to-peer is different. This computer server system. Compute server system. Actually, compute server system is the other name for client server system. Client server system. Other name for is client server system, my dear. Don't confuse. Computer server system is the other name for client server system. Okay? Client server system. Peer-to-peer is different, my dear. Peer-to-peer बोलो तो क्या है ना? There is application layer, physical layer, presentation layer, data link layer. Like this it will go, and here also physical layer, data link layer. Like this layers will go. Like this layers will go. So layer to layer communication. This is peer-to-peer. So here comes the physical layer, data link layer, transportation layer, network layer, session layer, presentation layer. Like this. Okay, I'm asking about this session PDF, sir. I don't know that. I think that will be available in the that will be available in the app. I think so. I think that will be available in the app. If you want, I will post in, but we cannot post. Okay. Chalo, enough for today, beta. So please collect these notes. So kaisa laga session? So I wish you all the best, my dear. I will post this session PDF. Savi, are you satisfied with this session? So please focus on computer networks topics also, CN topics also. Please study CN topics also. Please share your constructive feedback after the class. Thank you, Savi. I wish you all the best. If possible, we'll come with some more classes soon. Yeah, very nice. थैंक यू. आई विश यू ऑल द बेस्ट. अगर आपको कुछ डाउट्स है तो मेरा टेलीग्राम ग्रुप में आके बोल सकते हैं, पूछ सकते हैं. मेरा टेलीग्राम ग्रुप मैं बात इधर दे रहा हूँ, टेलीग्राम ग्रुप. आई एम गिविंग द टेलीग्राम ग्रुप మై డియర్ హియర్. ఇప్పుడు ఏం లేదమ్మా క్లాస్. ఇక నాకు ఆల్రెడీ 3 సబ్జెక్ట్ చెప్పాను కుమార్. నేను 3 సబ్జెక్ట్ అంటే మాటలు ఆలోచించి ఒకసారి. 3 సబ్జెక్టులు చెప్పినా కదా, COA, మెజర్మెంట్స్. చెప్తా. ఎనీథింగ్ ఇస్ దేర్, ఐ విల్ లెట్ యూ నో. I wish you all the best, Nana. Love you all. Take care. Bye bye.